irrespective, whatever is the method of preparation, the elements, they will be present in definite proportion of mass and volume. The proportion of their mass and volume will be same, whatever is the method of preparation. I hope you are clear with the concept. This was the law of constant proportion. Then now we will come to the topic of our chapter, that is atom. Atom is the smallest particle of an element. As I told you that in the further introduction part, that the matter which we are continuously dividing, a stage comes when they are not divided further, that is the smallest particles are obtained, we have termed it as an atom. So the smallest particle of an element, are termed as an atom. Now it may or may not have an independent existence, that is, it may be existing independently or it may be existing with some other things. So it can be existing independently or may not be also. Now they are very small in size. Their size is measured in unit nm, that is nanometer. They are measured in nanometer, which, so 1 nanometer is 10 raised to minus 9 meter. And hydrogen atom is the smallest of all. Its size is only 10 raised to minus 10 nanometer. Hydrogen is the smallest of all atoms. Now, atoms are represented by symbols. Basically, the atoms, generally, if we represent the atoms, they are represented in symbols. And these symbols were given by Berzelius. He was a scientist who represented the atoms in symbols. So, as if suppose if I take example of hydrogen, hydrogen is represented as H. If I take another is lithium, lithium is represented as Li. Okay, so this symbols we term as IUPAC. They are given on the basis of their IUPAC name. IUPAC, the full form is International Union of Pure and Applied Chemistry. This way we term them as IUPAC. So what is that? It approves the name of elements. It approves names of elements. Now, according to it, what does this IUPAC says? How to represent the atoms in their symbols, right? Symbol is the first letter of element or first two letters. As I told you, for hydrogen it is H. So either it is the first letter of element or first two letter. If I say lithium, it is Li. If I say sodium, it is Na. Okay. Then first letter is always written in capital and second letter is written in smaller case. Your example is of lead. Lead is written as PB, capital P, small b. It can't be written as small b, small p, capital B, or small p, small b. First letter is always written in capital, second letter is written in smaller. Now, here it is written that the first letter of the element is there or first two letters. But here in this example, lead, it is Le. So, how it is done Pb? How can we write down Pb? But some of the atoms, they are represented through their Latin names. So we are representing them as their Latin names. Let's study how. These are the Latin names of few elements. So first is antimony. See, the name of the element is antimony, but its Latin name is stibbium. So here the symbol is Sb. Then copper. The name of the element is copper, but Latin name is cuprum. So we are writing Cu. Then gold. Name is gold, but its Latin name is aurum. So Au. Then iron. So the Latin name is ferrum. So Fe. For lead, it is plumbum. So here Fb not, it is Pb. Plumbum, so Pb. Mercury, it is Hg. Why? Because its Latin name is hydrargyrum. Then potassium, K, it is kalium, Latin name. Silver, Ag, it is argentum. Then sodium, Na, natrium. Tin, Sn, stannum. And tungsten, W, which is wolfram. So students, these are the Latin names of some of the elements which you have to study, or if you want to directly remember the symbol using the name of the element, that is also a better way. Then the atomic mass of an element. As I told you in the previous slides that how to calculate the atomic mass. So here we are going to see it. So absolute atomic mass of atom can't be measured. We can't measure the exact atomic mass of an atom, but relative atomic mass can be known. We can calculate the relative atomic mass. Means if you say in mathematics, then approx, we can calculate the relative atomic mass. Then relative atomic mass of an atom of element is defined as average relative mass of atom as compared to atom of carbon taken as 12U. See, the most remarkable concept that Dalton's atomic theory proposed was that of the atomic mass. According to Dalton, Dalton said that each element had a characteristic atomic mass. Each element has an atomic mass. The theory could explain the law of constant proportion so well that scientists were prompted to measure the atomic mass of an atom, as we saw in the law of constant proportion, right? So, since determining the mass of an individual atom was a difficult task, so that's why the relative atomic masses were determined. Let's take an example. Compound, if we take carbon monoxide, CO, okay, carbon monoxide, it is formed by carbon and oxygen. It was observed experimentally that 3 gram of carbon combines with 4 gram of oxygen to form carbon monoxide. So 3 gram of carbon mixes with 4 gram of oxygen and it forms the carbon monoxide. So in other words, we can say that carbon combines with 4/3 times of its mass of oxygen, 4 by 3. Can we say that? Because 3 grams of carbon and 4 grams of oxygen. So the carbon combines with 4/3 times its mass of oxygen. Suppose we define the atomic mass unit as equal to the mass of 1 carbon unit. If atomic mass unit is defined as equal to mass of 1 carbon unit, then we would assign carbon as atomic mass of 1U and oxygen atom as 1.33U, right? So however, it is more convenient to have these numbers, that is as whole numbers or as near to whole numbers as possible. So if we can keep these numbers as whole numbers or near to whole numbers, but not like this way. Suppose if we take this as then we have to keep the atomic mass of carbon as 1.0U and carbon oxygen atomic mass will be kept as 1.33U. That will be difficult to measure. So that's why while searching for various atomic masses, scientists initially took 1/16 of the mass of an atom of naturally occurring oxygen as the unit. So they took it as 1/16 of the mass of an atom of naturally occurring oxygen. For carbon, they took as 1/12th of carbon atom. For oxygen atom, it will take as 1/16th of oxygen atom. This atomic mass, you have to learn it. It is already given in the table of your textbook. There is a table which is given on page number 35 in your textbook, with along with the element, some of the elements are given, and in front of that atomic mass of that elements are given, that you have to learn it. Okay, so we can define atomic mass as the number of times an atom is heavier than 1/12 of carbon atom, or we can say is heavier than 1/16 of oxygen atom. Whatever you need, you can take, but you have to learn the atomic mass of the elements. Plus, you have to learn the symbols for some of the elements which are given on page number 34. In a table it is given elements and their symbols. That also you have to learn it. So with this, that's all for today's session. So if you have any doubt, you can ask me. So your work is, you have to learn the atomic mass of the elements and symbols of the elements. The PDF of the chapter I will provide you in the class group. Thank you.